So the next step was to try the implementation itself. I will not report any result yet because some analyses are still missing. But well, the idea was mainly to I have to make a simple graph of what we did, but the digestive manure treated with the polymer, sedimentation for 4 days, and separation of phases, the liquid phase and the concentrated digested manure. And this is concentrated digestion manure that is going to be continued to the lime treatment. For the lime treatment, we got the solid phase. We treated. We didn't know how much lime we are going to be using, so we used different levels of lime. And to study the effect of this treatment, instead of going to a second continuous reactor, we did just a batch digestion to see the differences. And here again, the same figure, the digested manure with the polymer, the sedimentation, and then we have this concentrated digestion manure, or the solid phase, that was treated with 3 different levels of lime, 5, 15, and 30 grams lime. Then the treatments were in red. They were further studied in batch digesters. So we compared the digested manure, the concentrated digested manure, which is the control without the lime. And these are the results. This is a trial that is still going on, but there are some preliminary results. As we can see here, this is the production of methane. Milliliters of methane per gram VS. And the first thing that we can see is here, this is the control, the digested manure, that's the effluent from the first step, that is still producing gas. Remember that we got 140 milliliters methane per gram VS. With just digesting it 30 or 35 days more, we are getting 100 milliliters of methane more. Then we have this, there are 2 lines here, and this is both the concentrated digested manure without any lime, and we have the other treatment with the lowest level of lime. So we don't see any difference between both, but still there is higher methane production compared to just digested manure. And then we have the 2 levels, the higher levels with the lime, the one with 15 and 30, that are giving larger amounts of methane compared to the control. And what we see even that the system, the trial with the highest lime concentration is also showing no lag phase, which means that probably the carbon has been converted into available carbon. After some 20 days, both the one with 15 and 30 have all more or less the same amounts of methane. At 35 days of digestion, we have that the one with 15 grams of lime per kilo is producing 146 milliliters of methane per gram VS, which is the same amount that we got in the first step. So we could double the production of methane. Yes. And this is just the trials that we have done during the first year, and we will continue during the second year with the same concept by trying the second reactor also in a continuous way. And these are just preliminary results. It's all. Thank you.
Tack så mycket, Maria. Ska vi ta på engelska eller svenska?
Ja, på engelska eller på svenska.
Okej. Det är kul att få en inblick i hur man jobbar med att optimera biogasprocesserna. Jag har ganska dålig koll på den själv, så det var väldigt intressant. Har vi några korta frågor? Fråga till Maria. Ja,
kort fråga. Kan man använda enzymer för att öka tillgängligheten av det biologiska materialet?
Yeah, this is some interesting idea. I have worked with the föreläser, for example, from white rose fungi, and there is a known technique in the paper pulp and paper industry, in which it's possible to treat the lignocellulosic material with either the white rose fungi or either with peroxidases or lacases in order to increase the availability of cellulose and hemicellulose. But it's something that it has not been applied yet into this area of bioenergy and biogasproduktion. But it's possible because the technique is already there.